In this video, we're going to take a look at parallel lines and angle pairs that are formed when parallel lines are cut by what we call a transversal line. So there are four main postulates or theorems that we're going to take a look at today. So corresponding angles postulate states if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So your parallel lines are lines L and M in this picture over here on the right. And your transversal line is this other line that cuts through the parallel lines. And this postulate states that when that happens, you have corresponding angles that would be congruent to one another. So just for example, these two that are labeled, and there's two ways you can label congruent angles. There's the angle mark, which is just that little sort of curved line in the corner of that angle. And then there's also a tick mark that you can put. So either way in a picture indicates that those are congruent. All right, let's move on to the next theorem. Alternate interior angles theorem states if two parallel lines are cut by a transversal, then pairs of alternate interior angles are congruent. So there's a lot of words in that statement. Let's go over some of those. So we have our parallel lines L and M cut by this third line called our transversal. Here, I'll highlight that in green. And then there's pairs of alternate. So alternate means they're on opposite sides of that transversal. So like here's one side of the transversal and here's the other side of that transversal. Alternate means that they are on opposite sides of the transversal. It can also mean, or excuse me, that's probably a good place to leave that for now. Let me bring that back. All right, interior angles. So let's talk about the word interior. Let me grab another color. So interior is inside of the parallel lines. So this is what we call an interior angle if it's inside the parallel lines. Whereas outside here, which we'll look at in a later theorem, is exterior. So lots of words to consider, but nothing too complicated. You have interior angles and exterior angles. Alternate just means on opposite sides of the transversal. So that's a little crowded. I'm going to move that out of the way. And let's focus on what this theorem is really talking about, which is when you have alternate interior angles and you have two parallel lines cut by a transversal with alternate interior angles formed, those are congruent again. So they have that tick mark or that angle mark that looks like they're the same. All right. So we went over some words in our last theorem that will hopefully help with this next theorem. This is alternate exterior angles now. And this theorem says if two parallel lines are cut by a transversal, then pairs of alternate, so remember that's on opposite sides of the transversal. So alternate would mean like this one's on the left of the transversal and that one's on the right. So let's add our parallel lines, or L and M again. We are cut by a transversal and those angles are on opposite sides of the transversal, so we call them alternate. And then they are exterior because they are located on the outside of these parallel lines. So that's how we name them. They are alternate exterior angles, and they are once again congruent. So notice that's been kind of a common theme so far. There are three ways that these angles can be congruent. All right, so let's review for a minute. We have three that are congruent. Corresponding angles are congruent. Alternate interior angles are congruent, and alternate exterior angles are congruent. But in our last theorem, we are talking about what we call consecutive interior angles. So let's talk about that word for a minute. If we have two parallel lines, they are cut by our transversal, consecutive. Sometimes you see the word same side. So same side and consecutive, let me spell that better. Same side or consecutive anterior angles. So same side might make more sense, but we often see the word consecutive used. So they're on the same side. Notice like nothing's on this side over here. And they could have been on that side, but they would have to both be on the other side. So if two parallel lines are cut by a transversal, then pairs of consecutive, so on the same side of that transversal, they're consecutive interior angles, and they are considered supplementary. Remember, interior means they're inside those parallel lines. They're on the same side, or they're consecutive, which also kind of means they're like right beside each other. And they add up to 180, and they are supplementary. Because when any two angles add up to 180, we call them supplementary angles. Okay, so those are our 4 theorems and postulates. Let's take a look at 2 old concepts, and then we're going to look at some examples of how to apply these things. So something you've heard of before, hopefully, is vertical angles. So vertical angles are when 2 lines intersect. So we have these 2 lines that just cross each other. They intersect. Then we know that vertical angles are formed. So you have this angle across from this angle, and they would have the same measure. And then in the same way, grab a different color, we know that these 2 are across from each other. Those 2 lines are intersecting, so either pair of angles that are across from each other are congruent. And then if you notice, another quality of that would of course be that these 2 form a straight line, and they would add up to 180. But that leads us over here to this other thing that we need to review, which is called a linear pair. So a linear pair is when you have 2 angles that together form a straight line. And because they form a straight line, they add up to 180. They're supplementary, which helps us solve problems when we see these. So it's good things to know. These things will help you solve problems when they happen, and they show up often. So let's see. We have angle 1 is sitting right here. Let me make that a little smaller. And angle 2 is just right beside it. But we can tell together that those form a nice straight line. And so we call those a linear pair. They add up to 180, and they are therefore supplementary. So all those things apply when you see that happen in a picture. Now let's just take a look at some examples to get you started. All right, so if P is parallel to Q, and we can tell it is cut by a transversal right there. And then they told us that the measure of angle 1 is 105. And that's probably going to help us solve the rest of it. So it says find the measures of all the angles formed by the parallel lines cut by a transversal. So knowing that angle 1 is 105 degrees, you can really do a whole lot with that. Like you can start by finding angle 2, 8, or 7, just straight from that 105, because those are vertical angles. I'm just going to say that 7 would have to be 105 because it's right across the intersection of those 2 lines from angle 1. So let's just fill in as we go. So angle 1 is 105 degrees, and so is angle 7. And then 2 adds up with 1 to be 180. Let me grab another color. Let's see. So 2 and 1 add up to 180. So 105 minus 180, or excuse me, 180 minus 105 would be a better way to do that. 180 minus 105 gives us 75 degrees. So we know angle 2 and therefore angle 8 would be 75 degrees. So let's just write that over here. Now looking at the bottom of this figure, these angles at the top are related to the ones at the bottom based on what we talked about in our notes. So if I look at angle 1 is corresponding with angle 3. So therefore they would be congruent. But there are certainly other ways that you could figure it out. So let's say angle 1 and angle 5 are alternate exterior angles, so they would also be congruent. It's just another way you could look at that. So I'm just going to write 105, and we know angle 3 and angle 5 are congruent because they're vertical angles. And then if you look at the picture above, it's a parallel version of what you saw right above there. Like it's a mirror image, I should say, as a better word. Angle 8 is corresponding with angle 6, for example, or angle 8 is an alternate exterior angle with angle 4. So we could say those would both be 75 degrees. And I could actually keep going and put a lot of relationships together, but I don't want this video to get too long and drawn out. So hopefully that sounds good so far, and we can certainly talk about it more if we need to in class. So let's look at this next picture. If DC is parallel to BA, are the angles congruent or supplementary? So let's just put, these are our parallel lines this time. So notice those are actually like going in kind of a different direction than what we've seen so far, but that's okay. And our transversal looks like it's kind of horizontal this time, but all the same rules apply. So let's just take these one at a time. DHG. So DHG would be this angle right here, and angle HGA. So HGA is that angle right there. So we want to see if they're congruent or supplementary. So let's review a few things. Just take a look back over here for a minute. We had 3 postulates or theorems that state that angles are congruent. If they are corresponding, if they are alternate interior, or if they are alternate exterior, the angles are congruent. The only time they're going to be supplementary is when they're consecutive interior angles, or they're on the same side of the transversal. They're sitting like right next to each other. So if you look at these 2 angles, these are alternate interior angles. I'm just going to write that down. Alternate, I'm going to abbreviate though. Alternate interior angles. And therefore, they are congruent. The congruent symbol looks like an equal sign with a little sort of curvy line above that. That means congruent. So just do the best you can to practice writing that as you work on these. All right, number 2, let's grab a different color. I'm just going to move that out of the way for now. So FHC, let's look at that. F to H to C forms the angle right there. And then D to H to G forms this angle. So these 2 angles are actually part of our review. They are vertical angles. So vertical angles we know are congruent. So I like to kind of write the reason and what they are. So they are vertical angles, and that is why we know they are congruent. Let's look at the next one, which is just another number 2, but that's okay. Let's see. BGE. So I like to go over to the figure and draw B to G to E and put the angle in the middle. FHC, so F to H to C. So these 2 are alternate exterior angles. They're on opposite sides of the transversal, and they're outside of those parallel lines. So let's write alternate exterior angles, and therefore they would be considered congruent. All right, so let's clear that out and look at the next one. EGA, so let's draw from E to G to A, this angle right here, and then G to H to C. So G to H to C would be that angle right there. So these 2 are on the same side of the transversal, but they're not interior angles. So like they're not that one right there. These are corresponding angles. So corresponding angles are congruent. All right, and then AGH, so let's clear out that and grab one more or 2 more colors will do. All All right, so AGH, so A to G to H is that angle. And EGA is that angle right there. So these two are part of our review. These two form a straight line. So they are a linear pair, and therefore they are supplementary. I'm just going to write it all the way out. There's not really a symbol for supplementary, so you just have to write it. Okay, now let's look at this last one of this example. Let's see, I'll just do orange. So DHG, forms that angle, and angle BGH, so B to G to H. It's right there. All right, so these two are same side because they're on the same side of the transversal, and they're consecutive. They're like right beside each other. There's nothing that would happen in between the two. So these two are same side or consecutive angles, and therefore we know they are supplementary. And again, there's no symbol for that, so just write it out. All right. So let's move along to the next example, our last one. We're going to solve for x and y and explain our reasoning. So we have these angles. There's a couple ways you could go about this. I am just going to show you one of those ways, but you could certainly do this in some other ways. So I'm going to start, let's start with these two. So if I pick out these two angles, I notice that those are alternate exterior angles. Let me highlight. Well, let's see. We have parallel lines cut by a transversal, and they are sitting on opposite sides, so they're alternate, and they're outside of the parallel lines, so they're exterior, and therefore we know that they're congruent to one another. So let's say 4x minus 8 equals 3x plus 10. And we can say this because we know that alternate exterior angles are congruent. So that would be our reasoning. And now we're going to solve the equation. So I would just subtract 3x and bring down x minus 8 equals 10. And I would add 8, so I get x equals 18. All right, so we got x. We just need to figure out the y. So we can take a look at how y fits in this picture. So we have this angle that has a y included in it. And then the one right beside it, we now know what x equals, so that's going to help. These two form a straight line. So we know they are a linear pair. So I'm going to use that to help me solve for y. So let's say 3x plus 10 plus 11x. Can't read that. Let me move that out of the way for a second. Okay, make sure I got it all. 3x plus 10 plus 11x plus 2y would equal 180. But we know x equals 18, so that's going to certainly help us simplify some things. All right, so we have 3 times 18. Hold on one second. Let's see. So 3 times 18 will give us 54, plus 10 is 64. We have 11 times 18, which is just 198, plus 2y equals 180. All right, so 64 plus 198 is just 262. So you can fill in the 18 for the x and simplify that. Now you could certainly put all that in your calculator. I just worked it out by hand, but like if you wanted to type all of this in your calculator, you would just get the 262 right from there. So it's okay to write out steps. It's okay to type that in your calculator, but then bring it down to this step where we are now. So we have 262 plus 2y equals 180. We just need to finish solving for y. So let's subtract 262. We get 2y equals negative 82, and we just have to divide by 2. So we get y equals negative 41. and we have our answer. So we have x equals 18. We have y equals negative 41. And then let's just add our reasoning. So we were able to set those up and add them to equal 180 because, I'm just going to write it up here, a linear pair adds up to 180, or you could say it's supplementary. Okay, so that's it for our notes. Notice there's some videos attached to these notes at the bottom and the top. So you could review parallel lines another way and then get started on practice. But that's it for now. Thanks for watching.